In the summer of July 2025, Yellowstone National Park became the center of global attention when something strange began to happen across its vast and wild landscape. Visitors noticed that thousands of animals were moving in unusual ways. Elk, bison, deer, and even smaller mammals were leaving the open valleys and lowland areas where they normally roamed and were heading up toward the higher ground. The sight was dramatic, as herds that normally stayed spread out began to gather together and march toward the hills and mountainsides. Tourists and researchers captured videos of this behavior, and these clips quickly spread across social media platforms. The images of massive herds on the move struck people as both beautiful and unsettling. While to some it looked like a natural migration, others wondered if the animals were responding to something hidden, something humans had not yet detected. The reason so many people immediately grew concerned was because Yellowstone is no ordinary national park. It is home to one of the largest active supervolcanoes in the world. Beneath its forests, rivers, and hot springs lies a volcanic system so vast that, if it erupted on a large scale, it could affect not just the United States but the entire planet. While it has not erupted in about 640,000 years, the very idea of such a massive force beneath the surface has always caused unease. For decades, scientists have studied the Yellowstone caldera, as it is called, with great care, and its activity is closely monitored by the United States Geological Survey. So when animals began moving in unusual ways, many feared it could be a warning sign. The concern grew stronger because in the months leading up to this event, scientists had recorded small tremors in the Yellowstone area. These tremors were not strong enough to cause damage, but they were frequent enough to be noticed. Geologists described them as low-level seismic activity, signs of underground movement of the Earth. For most volcanic systems, such tremors are normal, but when combined with strange animal behavior, they take on a new meaning. Could the animals be sensing vibrations or changes underground that humans and machines had not yet fully measured? Some scientists suggested that the animals were responding to subtle environmental signals. It is well known that animals can sometimes detect gases released from the Earth, or slight temperature changes in soil and water, or even vibrations too faint for human senses. Over many generations, the wildlife of Yellowstone has adapted to this unique environment filled with geysers, hot springs, and shifting geothermal features. Their instincts may be finely tuned to detect changes in the land that people might overlook. While experts advised against panic, they admitted that the behavior of animals can sometimes be the earliest clue that something unusual is happening in nature. At the same time, Yellowstone remained open to the public. Tourists continued to arrive in large numbers, eager to see its famous geysers like Old Faithful, its steaming hot springs, and its spectacular landscapes. Yet the park rangers, along with scientists and wildlife experts, were paying close attention to the herds moving toward higher ground. They were mapping the routes, measuring the numbers, and comparing the behavior to past migrations. No one could say for certain what was driving the movement, but the very scale of it, thousands upon thousands of animals moving in unison, was impossible to ignore. As the animal migration captured attention, another discovery began to cause even greater alarm. A group of amateur researchers who had been monitoring Yellowstone's live cameras noticed something strange. Over several months, they observed the formation of a bulge beneath the park's surface. It was dome-shaped and seemed to be growing slowly but steadily. At first, some dismissed it as a trick of light or perspective, but the observers began to collect photographs and compare them carefully. When older images were placed side by side with more recent ones, the change was undeniable. The ground was rising. For those familiar with volcanology, this was a serious sign. One of the most common causes of rising ground is magma pushing upward from deep beneath the Earth. As molten rock moves into underground chambers, it increases pressure and lifts the surface, sometimes creating visible domes or bulges. The photographs suggested that this process was underway in Yellowstone. While ground uplift is not uncommon in volcanic areas, the size and consistency of this bulge made it more concerning. It hinted at the possibility that magma was gathering in a chamber beneath the park. The Yellowstone caldera has erupted 3 times in the past 2.1 million years, each time with devastating global consequences. The last eruption, around 640,000 years ago, blanketed large parts of North America with ash, altered the climate, and reshaped the landscape. Since then, smaller hydrothermal explosions and seismic events have occurred, but nothing close to a supereruption. Still, the geological record is a reminder that Yellowstone is not dormant but active. The formation of a bulge could mean that the underground system is shifting again. Scientists explained two possible causes for the bulge. The first and most likely was magma accumulation. As magma rises from deep in the Earth's mantle, it can create a dome-shaped uplift at the surface. The steady growth of the bulge supported this theory. The second possible cause was changes in the hydrothermal system. Yellowstone is famous for its geysers, hot springs, and fumaroles, all driven by underground heat. If underground water reservoirs became pressurized, they too could cause the surface to rise. However, the dome shape and consistency pointed more strongly toward magma. If the bulge was indeed caused by magma accumulation, the consequences could be serious. The risk of eruption increases as pressure builds underground. While it is impossible to predict exactly when or if an eruption would occur, scientists know that the danger becomes higher when large amounts of magma are rising. An eruption at Yellowstone could vary in size. At the smallest scale, it might release lava and ash locally, damaging the park and nearby communities but remaining limited in scope. At the largest scale, however, it could trigger a supereruption, one of the most catastrophic events possible on Earth. The impacts of such an eruption would be enormous. Locally, the explosion would devastate Yellowstone and the surrounding states, destroying forests, rivers, and towns. Ash would cover the land, making it difficult to breathe, killing crops, and collapsing buildings under its weight. Across North America, air travel would be grounded, power systems damaged, and millions of people affected by ash fallout. On a global scale, a supereruption would throw massive amounts of ash and sulfur dioxide into the atmosphere, blocking sunlight. Temperatures would drop worldwide in what scientists call a volcanic winter. Crops would fail, food shortages would spread, and climates would shift dramatically. Humanity would be facing one of its greatest challenges. These frightening possibilities made it clear that increased monitoring was essential. The United States Geological Survey already used satellites, radar, and seismic instruments to track Yellowstone, but the new developments called for even closer observation. Amateur researchers, too, were encouraged to share their findings, as independent eyes could sometimes spot things that official systems overlooked. Meanwhile, experts stressed the importance of public awareness. Panic would help no one, but accurate information could prepare communities for emergencies. Knowing what to do in case of an eruption could save lives. As scientists discussed the bulge, another series of events struck Yellowstone. A swarm of earthquakes rippled through the region. Earthquakes are common at Yellowstone, but the clustering of so many small quakes in a short period worried both researchers and the public. Then came an even more dramatic incident. Tourists visiting Biscuit Basin, one of Yellowstone's geothermal areas, witnessed a massive explosion. A hot spring erupted violently, sending scalding steam and debris into the air. Visitors on the boardwalk screamed and ran as the ground shook beneath them. Some filmed the event, and the terrifying footage spread quickly online. The National Park Service closed Biscuit Basin immediately, and geologists rushed to investigate. The explosion intensified fears that Yellowstone was becoming unstable. Soon after, suspicions arose about the official information being released. Some amateur analysts claimed that seismic data from the United States Geological Survey appeared incomplete. They noticed missing hours on certain days, gaps that fueled speculation about whether data was being withheld. Online forums filled with questions: were officials hiding something to avoid mass panic? Or was there more happening under Yellowstone than the public was being told? Graphs shared online appeared to show evidence of magma movement, and some observers pointed to a quake of magnitude 2.4 that had not been officially reported. People began demanding answers. Why had this information not been disclosed? Was the government keeping secrets about Yellowstone? Some argued that the reason for withholding details might be to avoid frightening people unnecessarily, while others suspected deeper reasons. Scientists tried to calm the public. Dr. Michael Poland and other experts explained that Yellowstone averages between 1,500 and 2,500 earthquakes every year. Most are very small, caused by the fragile crust, high underground temperatures, numerous faults, and active groundwater movement. On average, the park records 100 to 200 earthquakes every month. These swarms, they said, were part of Yellowstone's normal behavior. Yet the combination of animal migrations, rising ground, seismic swarms, and sudden explosions made many people uneasy. Adding to the mystery, scientists confirmed that animals were indeed migrating in unusual ways. Studies showed that some animals can sense changes in the Earth's electrical fields or detect gases released before earthquakes. These abilities explain why certain species flee before disasters strike. The fact that Yellowstone's animals were climbing to higher ground could not be dismissed as coincidence. Researchers noted that in the last 2 years, Yellowstone had shown 2 out of the 3 main indicators that suggest volcanic unrest, ground deformation and seismic activity. The third major indicator, increased gas emissions, was being closely monitored. By now, Yellowstone had become the focus of worldwide attention. News reports, documentaries, and online debates spread rapidly. Some people worried about the worst-case scenario, imagining a super eruption that would change life on Earth. Others trusted the experts, believing that while Yellowstone was active, an eruption was unlikely in the near future. Scientists themselves remained cautious, acknowledging that while much about volcanic systems is still uncertain, Yellowstone was clearly showing signs of change. The story of July 2025 was not just about science but also about humanity's relationship with nature. Yellowstone, long celebrated as a symbol of natural beauty, had become a reminder of the Earth's raw power. Beneath the geysers and valleys lay forces capable of reshaping the planet. The movements of animals, the trembling of the ground, the rising of the land, and the sudden explosions were all signs that Earth is alive, restless, and unpredictable. Humanity could only watch, study, and prepare, hoping that knowledge and caution would be enough to face whatever the future might hold. Yellowstone has always been one of the most carefully observed natural wonders in the world, not just because of its breathtaking scenery and unique geothermal features, but because it sits on top of one of the most powerful volcanic systems on Earth. For decades, scientists and researchers have monitored the area for any signs of unusual activity, and in recent years, the reports have become more detailed and more concerning. The indicators that have been recorded include a noticeable rise in seismic activity, meaning more earthquakes and tremors than usual, as well as an escalation in the number of gas vents appearing on the surface. These vents release gases from deep inside the Earth, and their sudden increase is often seen as a signal that something is shifting beneath the ground. Alongside this, researchers working inside the park have reported that new erupting vents and surface fissures have appeared. This forced officials to close off a popular boardwalk in the Upper Giza Basin, one of the most visited spots by tourists, because the ground had become unstable and too dangerous to allow visitors to pass through. All of these events have raised alarms and have led to more intense monitoring by scientists. The Yellowstone supervolcano is always under constant surveillance by scientists and government agencies because of its potential to cause catastrophic damage. While experts agree that the chances of another super eruption happening in the near future are low, they also stress that the consequences of such an event would be enormous. A full-scale supereruption could release thousands of cubic kilometers of ash and pyroclastic material into the atmosphere, enough to blanket entire states and disrupt life far beyond the United States. The ash cloud would circle the globe, altering the climate, severely damaging agriculture, and endangering human health for years. Even smaller events, such as hydrothermal explosions or minor volcanic eruptions inside the caldera, could cause significant local damage, putting the park itself and surrounding communities at risk. For this reason, scientists make it clear that public safety is the main reason Yellowstone must be studied so carefully. At the same time, monitoring Yellowstone also serves another important purpose. It gives scientists a rare chance to understand volcanic processes and hazards in ways that cannot be studied anywhere else. Yellowstone is essentially a natural laboratory for geothermal and volcanic activity. By keeping a close eye on it, scientists gain valuable insights into how caldera systems function, how magma moves beneath the Earth, and what specific conditions trigger eruptions. This knowledge doesn't just help in understanding Yellowstone, it helps improve predictions and preparedness for volcanic events around the world. If scientists can better understand the warning signs of an eruption here, they can apply that knowledge to other volcanic regions where millions of people live close to active volcanoes. One of the most important tools used in Yellowstone is seismic monitoring. The Yellowstone Seismic Network, run by the United States Geological Survey in collaboration with the University of Utah, is made up of more than 50 seismometers spread across the park. These instruments are highly sensitive and can pick up even the smallest earthquakes. They record earthquake activity and provide scientists with data about how magma and geothermal fluids are moving beneath the surface. When seismic activity increases, it often suggests changes in the volcanic system and could serve as a warning of something larger developing. Another method is ground deformation monitoring, which tracks how the surface of the Earth rises or sinks in response to magma movements. This is done using GPS stations, satellite radar, and borehole strain meters, which measure ground shifts with extreme accuracy. Even small uplifts or subsidences of the ground can reveal pressure changes in the magma system and indicate potential volcanic activity. Geochemical monitoring is also crucial. Yellowstone is filled with hot springs, geysers, and fumaroles that release gases such as carbon dioxide, sulfur dioxide, and hydrogen sulfide. By collecting samples of these gases and thermal waters, scientists can analyze their composition and detect changes that point to magma rising or shifting. For instance, a sudden increase in sulfur dioxide might suggest new magma is closer to the surface. On top of all this, remote sensing technology, including satellite imagery and aerial surveys, adds another layer of observation. Satellites with thermal imaging can pick up temperature changes on the surface, while spectrometers can measure gas emissions over wide areas. Together, these tools make Yellowstone one of the most closely studied volcanic systems on the planet. The continuous monitoring of Yellowstone has another major purpose. It allows scientists to create and maintain early warning systems. If they can detect signs of increased volcanic activity in advance, they can alert government agencies and the public in time to take precautions. Effective communication and coordination between federal, state, and local authorities are critical so that emergency plans can be put into action without delay. The data gathered not only informs scientists but also shapes public safety strategies, emergency drills, education campaigns, and infrastructure planning. By understanding the risks, communities can reduce the potential impact of volcanic hazards. In recent years, researchers made an astonishing discovery about Yellowstone's underground structure. Using seismic tomography, which works much like a CT scan for the Earth by measuring how seismic waves travel through different types of rock, they uncovered a previously unknown source of partially melted rock large enough to fill the Grand Canyon 11 times over. This discovery revealed that Yellowstone's volcanic plumbing system is even more complex than previously thought. Earlier, scientists already knew of a massive magma chamber beneath Yellowstone that was linked to its past catastrophic eruptions. But the new research, published in the journal Science, identified another, much deeper reservoir that is more than 4 times larger than the previously known chamber. This deeper chamber does not necessarily increase the risk of an eruption, but it gives scientists valuable knowledge about how magma travels from deep within the Earth's mantle to the surface. The newly discovered reservoir is blob-shaped and sits in the lower crust, around 12 to 28 miles beneath Yellowstone. Its estimated volume is 11,500 cubic miles, which is over 11 times larger than the Grand Canyon. Most of this chamber consists of solid and porous rock with scattered pockets of molten magma, of which only about 2% is fully liquefied. Both the upper and lower chambers sit above a plume that rises from the Earth's mantle nearly 40 miles below. This plume carries hot material upward, fueling Yellowstone's geothermal and volcanic activity. While scientists had suspected such a reservoir might exist, they had never been able to confirm it until now. Using earthquake data and tomography, they were able to visualize the magma system in unprecedented detail, providing a full picture of Yellowstone's underground. Alongside this, Yellowstone experiences frequent earthquake swarms. Unlike normal earthquakes, which usually feature one large quake followed by smaller aftershocks, swarms are groups of many small and medium-sized earthquakes happening in the same area over a short period of time. Yellowstone experiences thousands of earthquakes each year, most too small for people to feel. However, some swarms can be intense and long-lasting. For example, in 1985, a major swarm near Lake Hebron included more than 3,000 quakes over 3 months. Another swarm in 2008 near Yellowstone Lake drew significant scientific interest. More recently, beginning in late 2021 and continuing through 2022, Yellowstone experienced another swarm with hundreds of quakes, some as strong as magnitude 4.5, clustered near the Norris-Giza Basin and the caldera itself. Scientists closely tracked this swarm with their instruments, analyzing the depths, locations, and patterns of the quakes. Earthquake swarms in Yellowstone are driven by a combination of tectonic forces and volcanic activity. Yellowstone sits on a hotspot, where heat from the mantle rises and thins the crust. This creates cracks and faults that slip when stress builds, causing earthquakes. The rising magma and the circulation of hot water and steam beneath the surface also trigger seismic activity. Although swarms can sometimes precede volcanic eruptions, the majority do not lead to one. Based on the latest data, experts concluded that the 2021 to 2022 swarm was not a sign of an imminent eruption. Still, such swarms highlight the importance of being prepared in case the situation ever changes. If Yellowstone were to experience another super eruption, the destruction would be unimaginable. Within the first 50 to 100 kilometers of the caldera, everything would be annihilated by explosions, ashfall, and pyroclastic flows, which are deadly surges of hot gas and volcanic debris that move at speeds faster than cars on a highway. Wildlife, vegetation, buildings, and even entire landscapes would be buried or incinerated. Beyond the immediate area, states across the American West would be blanketed in ash, in some places measuring feet deep. This ash would collapse roofs, disable power grids, destroy crops, and shut down highways and airports. Air travel could be halted across the continent, and the economic consequences would ripple across the world. The ash itself would also cause serious health issues. Fine volcanic ash particles can lodge deep in the lungs, causing respiratory illnesses, especially for people with asthma or other conditions. Masks and air filtration systems would be essential for survival in heavily affected areas. But perhaps the most devastating impact of a super eruption would be on the global climate. The eruption would send sulfur dioxide and other gases into the upper atmosphere, creating sulfate aerosols that reflect sunlight. This would cause a volcanic winter, where global temperatures drop significantly for years. Such a change could shorten growing seasons, reduce crop yields, and create widespread food shortages. Past volcanic events, like the eruption of Mount Tambora in 1815, which caused the year without a summer, give scientists a glimpse of what Yellowstone might unleash on an even larger scale. The environmental consequences would extend further. Ash and chemicals would contaminate lakes, rivers, and streams, disrupting aquatic ecosystems and killing species that rely on clean water. Plants and animals across North America could suffer mass die-offs or forced migrations as their habitats collapse. Biodiversity could be permanently reduced. The economic costs would be staggering as well, with trillions of dollars in damages, lost crops, destroyed infrastructure, and global trade disruptions. Recovery from such an event would take decades. Despite these terrifying possibilities, scientists emphasize that the chance of a Yellowstone super eruption happening in our lifetime is extremely small. The volcano has erupted only 3 times in the last 2.1 million years, with the last eruption occurring about 640,000 years ago. Smaller eruptions, like lava flows or hydrothermal explosions, are much more likely, though they would still cause local damage. The key, scientists insist, is to continue monitoring, continue studying, and continue preparing so that humanity is not caught off guard. Yellowstone is both a threat and a gift, a reminder of the immense power of our planet, but also a natural wonder that teaches us more about Earth's inner workings with every discovery.